Hi, today we're going over section 7.4, which is investments and loans. So first thing we'll talk about is annuities, which are a series of deposits or payments made at equal time intervals. So to calculate the amount of an annuity, we have a formula A equals R times bracket 1 plus I close bracket to the power of n minus 1 close bracket over I, where A is our amount in dollars, R is for regular payment or deposit in dollars, I is for interest rate per compounding period as a decimal, and N is the number of deposits or payments. So for example, regular deposit of $200 is invested in a savings account at the end of each month. The interest rate is 3% compounded monthly. What is the amount of annuity at the end of 30 years? So writing out what we have, first thing we come across is our regular payment of $200. Interest rate is 3% compounded monthly. So our interest would be 0.03 divided by 12 because it's being compounded monthly. So that gives us 0.0025. Our N value is how many compounding periods total. So it's compounded monthly. So that'd be 12 times 30 years. So 360. And now we're ready to go in our formula. So we have A is equal to R times 1 plus I to N minus 1 over I. So we have R value of 200 times 1 plus our interest rate of 0.0025 to the power of 360 minus 1 divided by 0.0025. So first thing I would do is add these together and go to the power of 360. So that's going to give me 200 times 2.4568 minus 1 over 0.0025. Next, we calculate this row, so I would subtract the 1, multiply by 200. So that gives us 291.37 divided by 0.0025. And that leaves us with an amount of $116,547.38. Next example, suppose you want to save for a down payment of $50,000 to buy a home in 12 years, invest in a stock portfolio that pays 4.8% interest compounded monthly. What should your monthly deposit be? So we're going to solve for R in this case. So writing out what we have our amount, which is 50,000. We have our N is 12 years compounded monthly, so 12 times 12, so 144. We have our interest rate is 4.8%, which is 0.48 divided by 12, which is 0.004. And now we want to solve for A value. So we have A is equal to R times 1 plus I to the power of N minus 1 all over I. We'll substitute what we have in, so we have 50,000. equals our R times 1 plus 0.004 to a power of 144 minus 1 all over 0.004. So first thing I'll do is get rid of this fraction by multiplying both sides of our equation by 0.004. So that gives us 200 is equal to R times 1.004 to a power of 144 minus 1. So I'll do this part next. So I've got 200 is equal to R times 1.004 to a power of 144 is 1.7778 minus 1. So that gives us 200 is equal to R times 0.7778. Divide both sides by the 0.7778. And that gives us an amount of $257.44. Okay, so these annuities have dealt with ones where we're investing. We have a slightly different formula for if we're borrowing. So for borrowing, it's present value of an annuity. So present value is amount that ends up being paid in out or how much is owed. R is the regular payment in dollars, I is interest rate per compounding period, and N is the number of payments. So first example, person buys a washing machine and dryer. He pays $100 a month for 2 years at an interest rate of 2.4% compounded monthly. What's the present value of the loan? Okay, so we know our R value is 100. We know our N is 2 years times 12 because it's compounded monthly, so that's 24. We know our interest rate is 0.024 divided by 12. So that would give us 0.002. And we want to know our present value. So our present value formula is PV is equal to R times 1 minus 1 plus I to the power of N, to negative N, I should say, divided by our interest. So filling in what we have, we've got present value as our R value of 100 times 1 minus 1 plus 0.002 to the power of 24 divided by 0.002. So we need to calculate what's up here first, and that's the negative 24. So we have 1.002 to the power of negative 24. So that gives us present value is equal to 100 times 1 minus 0.953 over 0.002. Calculating this top row of 1 minus that answer times 100. So we have 4.68 divided by 0.002. We get present value of a loan of $2,341.03. Okay, next example, a person has saved 500,000 for retirement. So that's going to be their present value. Investment earns 3.6 compounded quarterly. So we know our interest is 0.036 quarterly. So divide by 4. So that's going to give us 0.009. Our N, because it's quarterly, would be 4 times, we're planning on taking out for 30 years. So N, 4 times 30, so 120. And they want to know how much they can withdraw each time. So we're going to solve for our R value. So we have PV is equal to R times 1 minus 1 plus I to the power of negative N over I. So we'll start substituting our values in. So we've got 500,000 is equal to R times 1 minus 1 plus 0.009 to the power of negative 120 all over 0.009. So first thing I would do is get rid of this fraction by multiplying both sides by 0.09. So that gives us 4,500 equals R times 1 minus, calculate what this is, so that's 1.009 to the power of negative 120. That's 0.3412. That gives us 4,500 is equal to R times 0.6588. Divide both sides by our 0.6588. And that gives us $6,831.02. So I can take that value out 4 times a year until they're 95. Practice work for this section can be found at page 652, numbers 3 to 19.